Form 3 Mathematics, Topic 2, Approximation and Errors. Now, in Lesson 1, we will be discussing estimations and approximations, and then we'll also look at round-off error and truncation error. So to begin with estimations and approximations, we have a question to guide us. Round off each number to one significant figure and hence estimate 840 times 2945 all over 59.67. So the solution to this, we will first of all begin by estimating each and every number. For example, we are told to round off 840, 2945, 59.67 to one significant figure. So beginning with 840, when we round off this to one significant figure, we will have 800. Then for 2945, we have it approximated as 3000, that is to one significant figure, and also on the denominator we have 59.67. so this approximates as 60 to one decimal, or rather to one significant figure. So next we will have 840 times 2945 all over 59.67 approximated as, now in place of 840 we have 800 times, in place of 2945 we will have 3000 all over, in place of 59.67 we will have 60. So this gives us 40,000. So this 40,000 is a rough estimate of the value we should get when you work out the actual values we had, that is 840, 2945 and 59.67. So estimates are commonly used, especially when you want to carry out your calculations very fast. So you use rough estimates. So rough estimates you can get by rounding off to a given number of significant figures or decimal places. Next we have an exercise for you. Round off each number to 2 decimal places and hence estimate this. So try to work it out and see if you arrive at 0.8855. So next we are looking at the round off and truncation error. So here we have a question: find the error when 0.09 recurring is rounded off to one decimal place for part A. So the solution to this, we first of all must know that round off error is obtained as the absolute value of the difference between the actual value minus the rounded value. So that for our case, the actual value is 0.09 recurring, which can also be written as 0.0909 recurring, and that as a fraction is 1 over 11. The rounded value would be given as 0.1. Remember, we are rounding off 0.0909 to one decimal place. So that is the value expressed to one decimal place. So that finally, the error we're looking for that is the round off error, is therefore obtained as the absolute value of the actual value which we had as 1/11 minus the rounded off value which is 0.1. Now we need to remember that the rounded off value is an estimation, so it's approximately equal to the actual value, but the variation leads to some error which may be slight, so that is what we want to determine here. So the round of error for this case, when we subtract, we have 1/110. Well, for part B, we are going to talk about the truncation error. So first, truncation error is just the absolute value of the difference between the actual value minus the truncated value. So for this particular case, the actual value still remains 0.09 recurring, which we still have it as 0.0909 recurring, and that is 1/11. And the truncated value will be 0.09. Now remember, for this particular case, when you truncate 0.0909 recurring to one significant figure, then we begin counting the significant figures from here. So this is the first significant figure, and you count towards the right, and because it's one significant figure, then it's 9, and then the next value is less than 5. So truncation means we chop off so that our value remains 0.09 when truncated to one significant figure. So from there, we can now get the truncation error, and the truncation error, we will simply have the actual value, which is 1/11, minus the truncated value, which is 0.09. Now when this is worked out, we get 1/1100. So that's it for that part. Well, next there's a question for you here to try. Find the error when 0.1 recurring is rounded off to one significant figure. Try to work it out and see if your answer is 1/90. Otherwise, thanks for your patience. See you next time.